Okay, so we're going to do one variation on decomposition here. It's going to be really quick, and I want you to take out some notes and follow along with me if you could. But regular decompositions essentially is one thing breaking apart into two, and we may have seen it look something like this. AX breaks apart into A and X. And this is what normally happens. However, when we have three things, when we have a metal with a carbonate, or if we have a metal with a hydroxide, or if we have a metal with a chlorate, the way things break apart is a little bit different. Now, this M stands for any metal. So these formulas may look a little different depending on what the charges are, but any of those three, they break apart differently. So let's start with the metal carbonate right here. So MCO3. What happens is this, is that the metal actually grabs onto an oxygen, forms a metal oxide, and then CO2 gets kicked off. So anytime you see a metal carbonate, it will always form a metal oxide and carbon dioxide. Now, we could pick any metal randomly, and I'm going to just pick lithium, right? Lithium has a +1 charge, and whenever you're writing a formula, remember, you have to balance the charges. So that would be Li2CO3, because carbonate is a 2- and lithium is a +. Now, when we break it apart, now that lithium, which is our metal here, is going to form a compound with oxygen. Again, lithium is a +1 and oxygen is a -2, so that's going to give us Li2O, and then the CO2 never changes. Now, you may say, well, wait a second. This says M, and this is Li2. Well, depending on what the charge is on the metal, it will be different. Now, this is just doing it with the formulas. You could also have written it like this. I could have given you this at the top, and this is how it'll be written on in your work. It'll be lithium carbonate, and it will have an arrow. Now, if you see lithium carbonate with an arrow, you're going to realize, oh, that's one of the weird ones that breaks apart differently, and your product would be lithium oxide plus carbon dioxide. As I said, there's three different weird ways that things react. So that's metal carbonate. The next one is a metal hydroxide. And what happens with metal hydroxides is that metal hydroxides, they break apart into metal oxides plus H2O. Now again, the metal will change, but everything else won't change. So let's say we took a metal like calcium, and let's say the problem was this. Calcium hydroxide, and we saw an arrow. Well, the metal is calcium, which means that on this side, it's going to go together with oxygen, and it's going to become calcium oxide, and then the water is also there. Now, when we write it down, we have to balance off the charges. Calcium, if you take a look on the periodic table, is a Ca2+. So we're going to write CaOH in parentheses 2. And again, when we go to this side, it doesn't matter what we've written on the left-hand side. Again, this is going to be calcium with a 2+, so this is going to be Ca2+ and O2-. That gives us CaO, and it forms H2O. Now, this is a balanced equation, because if you take a look, we have one Ca, two O's, and two O's, and two H's and two H's. It's kind of fluked that this happened. And over here in the corner, I'm just going to keep a running tally of our different templates. So a metal carbonate will form a metal oxide plus CO2. A metal hydroxide is really, really similar in that it forms a metal oxide, but in the case of the metal carbonate, you have a carbon and it forms carbon dioxide. When you have a metal hydroxide, it ends up forming water. The last type is a metal chlorate, and I'll write the template over here. It forms a metal chloride plus oxygen. So anytime we see something with a metal chlorate, the way it's going to break apart is going to be different than we would normally assume if we just had two random things in a compound. So let's say I took any metal. Let's go with cadmium chlorate. And you saw an arrow. Well, what will it form? Well, the metal, isn't it cadmium right here? So it's going to form cadmium chloride. Plus oxygen. Now, if you get this far, then it's a matter of just doing on a compound. So cadmium is Cd, 2+, chlorate is ClO3-, and when we put them together, we end up with this. Similarly, on the other side, we have cadmium and chloride. So that's going to be Cd, Cl2. Check the charges to verify that I'm doing this correctly, and then you have O2. Now, when we balance off the charges, we have a Cd here and a Cd here. We don't have a ClO3 on the other side, so we can't count just the number of Cl3s, but don't we have a Cl times 2. Wouldn't that be 2 Cls? And here, don't we have 2 Cls? And then look here, don't we have 6 oxygens, 2 times 3? And here we have 2. So can we just put a 3 right here and be balanced? Now, those are the 3 main ones. And this box right here that I'm making terribly, this is the templates that you're going to have for any decomposition that's weird. What you also need to be aware of is that if something is decomposing in one direction, it is a synthesis in the opposite direction. So you'll often see this one right here, we have a metal oxide plus water, going backwards to form metal hydroxide. So if you see that, realize that's kind of a weirdest way of doing this. Now, there's one last thing I want to show you here, and then we'll be done, and that's decomposition of an acid. So if you're going to decompose an acid, what we simply do is subtract water. And what do I mean by that? Well, there's 2 main acids that you're going to face. One is sulfuric acid, and the other is carbonic acid. Now, it's kind of important that you know what these acids are, but I'm going to write them out for you. Sulfuric acid is H2SO4. Now, when I say subtract water, what I literally mean is, on the other side of the equation, you're going to take out water. And since water is 2 hydrogens and an oxygen, here you have 2 hydrogens and 4 oxygens. When you subtract them out, you're going to end up with SO3. This is actually how it breaks apart. But when you name it, it's really important. We know that water is just water, or if you want to get fancy, you can say dihydrogen monoxide, but I don't recommend that. But then you have SO3 over here. Now, SO3, you might be inclined to say is sulfite, but it's not, because sulfite only exists when it's part of a compound, or if I had a 2- outside. Here you have 2 different nonmetals interacting with each other, so this would be sulfur trioxide. The other acid you're going to face, this is one, the other acid you might face is carbonic acid. And carbonic acid is H2CO3. And similarly, what you're going to do is you're going to pull out water. So you're just going to put water out here, and then you're going to subtract the water from this, and you're going to end up with CO2. And when I do that, you're going to end up with carbon dioxide plus water. So what I would suggest is this. Anytime you see an individual compound just sitting there by itself, you're just going to split them apart, because that's what we do with decompositions. However, if the decomposition happens to be one of these 3, a metal carbonate, a metal hydroxide, or a metal chlorate, you're going to have to follow this template to write what the products are. Similarly, when you deal with the acids, you're going to have to just subtract water, and I can't see me giving you more than like sulfuric or carbonic acid. Anyway, hopefully this has helped. If you have questions, come in and talk to me. Have a blessed day.